Okay, Mr. King.
Hey, Mr. King and his new bride Jessica. This
How you
poor
doing,
guy.
Jessica?
How old are you?
31.
31-year-old who had a amputation secondary to diabetes about a year ago. The thing was, he was engaged to his wife, and then he ran into this problem, got an infection on his toe, and next thing you know, headed to an amputation. And she stayed with him anyway, and they got married. But what he promised her that he would walk down the aisle on their wedding day. So together they fashioned the prosthesis, and it allowed him to walk. He's one of these guys that's in a situation where he doesn't have access to health insurance these days. Take a look down inside the socket. Right. What he did was take a couple of crutches and contour it to actually create a frame-type socket and wrapped it with duct tape to get some contact.
I got those bands.
Oh yeah,
those
two clamps. Yeah, pipe bands. Yeah.
Put those on it, and I had some towel out on it. Screw it together, a few screws.
Yeah. He screwed it to a shoe stretcher to create a prosthetic foot. They were able to put a shoe on it. I bet you were able to dress up. Nobody could even see. Right? By the time you put your pants on and everything, nobody even knew he was an amputee.
Really good, comfortable.
Actually, you see where.
No, that's good.
No, you see where the.
Right, where the bars hit. Sure, you got
that-
pressure. Sure.
Where that part
right
there,
of
like
course.
on that side.
Right, because you can't really mold it. And now when we can make your prosthesis today, we're gonna take an impression of your body, so you got total contact. You're gonna love the way it feels compared to that. But it worked. I mean, it'll get you down the aisle. I mean, it's not the kind of thing you use every day because you're gonna kill yourself if you do. But it did its job, you know. Necessity is the mother of invention. There's the line, and that's what you can do. He did the right thing, you know, and also he proved to himself that it's not the end of the world. Now you know what it feels like to walk on these things. No big deal. If the amputation is below the knee, over 98% of the patients are successful with the prosthesis every day after the therapy is complete and their complete rehab is over with. So, 1 to 2% fail. And the only reason why that 1 to 2% fail is because that's a small group that can't even tolerate the normal forces inside a prosthesis. I'll give you your arm, I'll show you what the normal force is. Does that hurt? But you feel pressure. Some people can't even take that. So what we do is we take an impression of your residual limb, okay, with a plaster wrap, okay, and that impression is what gives us the model to make the socket, to make the prosthesis. But that model, if I was to take that model and just make a leg over that model, believe it or not, it'd be way too loose because the model is going to fit on you like this. So we have to kind of fit like this to make it work. Plus, you being your age and your activity level, your estimated activity level, you're going to run on this thing. And the more active you are, the more you're going to shrink. The shrinkage is directly related to your activity level. You could wear a leg all day long, but you're not going to shrink. But if you're on it and walking, that's when you shrink down. You probably noticed it even in the one that you made. It's okay in the beginning, but after a while it starts to nag you when you put more weight on it because you're actually shrinking and you're starting to sink in deep and you hit the bottom. All right? So, knowing that you're going to shrink, the way we're going to build this prosthesis is to kind of forecast the shrinkage. You got a prosthesis there? Give me one with an insert. Thank you. We're going to forecast the shrinkage. So what we do is, from experience over the years doing this stuff, we kind of estimate how much we think what you're going to look like 3 months down the road. So I'm going to take this cast, and then I'm going to reduce that cast equivalent to about what I think you're going to look like in 3 months after you've been walking on this leg. All right, we're going to reduce it down to that size. Of course, that's way too small for you to wear now. So how do you get around it? Then we make an insert that fits inside the leg. The insert is equivalent to a combination of socks that's about this much. So when you first start on this leg, you're going to walk on the hard socket without the insert in it. And as you shrink, you're going to add, this is the insert, see? As you shrink down, you're going to keep adding socks and adding socks and adding socks. When you get to the point where you have a big load of socks and they're becoming a pain in the neck because they're binding in the back and they get too bunchy, then you take the socks off and replace it with this part here. And that insert is what's going to give you life out of the prosthesis because these things are too expensive to replace every 3 weeks, especially since you're a new amputee. The body, I know you don't wear false teeth yet, but anybody who wears dentures will tell you that when they first get that part that fits in the gum, it feels like it was made for someone else. But eventually the gum actually takes the shape of the device that's pressing on it, the denture. and they become more comfortable as time goes on because the gum actually molds around the denture, and that's when the comfort increases. The same thing happens here. If I was to make this model in a shape that's awkward, sooner or later your stump would actually look like that shape. So knowing that, we could do a lot of manipulation with it. The insert also gives you the ability to modify the fit. So if I put a little pad in here, someplace on the insert, once that insert goes into the socket, it puts an increased pressure area on it. So if you're getting too much pressure over the front of the bone, you can put pads on the side, which makes a relief for the front. That's what this thing is really valuable for later on, because you can still modify it. You can't go inside that socket and glue pads onto it to change. Another part of this insert is, you don't want, the idea is to have pressure down here, but not weight bearing. You want contact, but not weight bearing on the bottom, because you've got nothing but cut bones down there. So what you're going to do, that insert, that white thing in the bottom is what we call a distal end pad. It's a pad that fits in the bottom, and that's an inch thick. So if you're out running around and you're not managing yourself properly with the socks, you start to sink in a little deep, you hit a soft. Now we're going to talk about the suspension. The suspension is the part of the prosthesis that holds it on. Of course, you got two things working for you and against you. When you step on it, you have compressive force going into it because you're stepping into it. And then when you carry it to the next step, there's a destructive force because of gravity and momentum. It wants to pull away from you. So what you do at that point, when you go into swing phase, as you carry that leg into the next step, you got to hold it on somehow. This is a gel liner, some of the new technology. It's been tried and true, very successful. There's a pin that screws into the bottom of this thing. It's serrated, and it goes into a lock inside the socket. So today we're going to roll on this liner and take the impression over the liner so that I have an image of what you look like inside the liner. Also, another nice thing about these is these liners come in 3 different thicknesses. This is the 3mm, the thinnest, okay? So if you shrink down a lot, I can put you in a thicker one. So instead of wearing all the socks, you just wear a thicker liner. So I make these 3, 6, and 9mm. 9mm is kind of like a truck tire. But it gives you options so that you don't have to replace the leg.
Right.
Alright, so to put this on, you turn it inside out, take the shrinker off. What I need you is in the position that you're going to be in walking. When we sit, we tend to roll out with the hips. So that's what I want you to do. Now the liner, okay, see how the liner is? It's printed on the inside and the out. Because you want to roll this on the same way every day. You don't want to rotate it. So when you put it on, the way to do this when you start getting dressed as an amputee is you peel this all the way back. You don't want to cup this thing and trap air, because if you trap a pocket of air, that becomes like an oven, and you'll sweat like crazy inside that little spot. The reason why you actually sweat less with this is because you're trapping the perspiration against the body and not allowing it to evaporate. Once you trap it against the body senses the moisture content and stops sweating. That's how our bodies work. We actually control our temperature with perspiration. You know, that's why when you get hot, you sweat. So peel it all the way back. I'll go over this with you tomorrow when you get your prosthesis, but you just position this where the ankle's going to be, and the pin will be on at that point. I just don't want it on now. Now, what do we do since he's active? Where do I want to place this? In the back or in the front?
Look at in the front.
That's the pin. I want the pin a little bit more anterior. Why? The resistance, because this endoflex. Okay? When you place the pylon more anterior, it's going to give them more resistance on the toe, so they don't get more performance out of the foot. If I place the pin back there, he's already over the toe now, he's not going to get any propulsion out of that foot. What I'm looking at is at your alignment, because the prosthetic foot has been placed in a place where it's going to work for you. And you saw on the one you made. If you put the foot out left field, you couldn't walk on it. So the idea is through the knee, and that should give you where this pin is. I think that pin should go over a little bit. See what I mean? So we're going to put it on again and move the pin over a little bit this way. All right. Good. Now, next step. This is just a bag to protect the lining in here from plaster. I need you to grab this on the sides like this and just pull up a little bit. Yeah, you see, you would have left me a little more sock. We would have been nicer, you know. Give me a little, that's it. See, because I want this leg in line with the direction that you're walking. When we sit in the chair, we always tend to roll out like this. So I need to look at it like you're walking. That's what you want. Good. What I'm doing now is I'm marking all the bony prominences of his body that we have to address when we make the prosthetic socket. All right, of course, now you don't want to move at this point. This is the patella, This is the center of the patella tendon. This is the lateral tibial flare. This is the marking out the crest of the tibia and the angle of the tibia. Okay, that bone is right along there. If he's got a sharp, they did a very nice amputation, by the way. They did a clean job, and it's good length. Perfect length. Then if there's any bony problems down here, I'll mark them off. This is the fibula head. Now I'll ride down here and look for the distal fibula. And if it's prominent, I'll mark that too. In his case, it's going to be fine. We'll also mark underneath the medial flare, right in here, the medial is inside, because that's an area that can tolerate a lot of pressure. Yeah, you can take a lot of weight there. So I mark it. When we fill this cast with plaster, because we're going to take a negative wrap now, okay? That's going to be a hollow piece, that's your image. But how do I turn it into a positive? Well, you fill it with plaster. All right, and when you fill it with plaster, the wet plaster will transfer the ink from one side to another.
How about that?
Because of this pencil. And that gives me those references in the plaster model now, because once I'm in a hard piece of plaster, I can't feel it anymore, feel what's soft and what's hard anymore, it's all hard. First plaster wrap, we put a bag and make this cast and kind of give it some shape, and then that's your socket. Done. Next step, now I need you to let go of that sock and just relax your knee like you're asleep. That's it. Good. Let it go, let it go, let it go. Good. And the reason why I ask you to do that is because when you let the muscles loose, now I can feel around and feel through the muscles to get to the bones. Because what you're going to do basically is carry a lot of your weight at the knee. And that's why we're applying pressure just below the kneecap. That's kind of like how it's going to feel in the leg. A little pressure in the back and a little pressure on the front, but that kind of perches you at the knee so you don't sink in too deep. A lot of your weight's going to be taken here. Basically, you're going to distribute the weight forces between probably 60-70% at the knee, and the rest just by compressing all the way around. Now we got your impression. So that's the model, okay? I'm going to remove this now. Nice. Hold my bag. Take out the stocking. Now watch this. I'm going to remove this knot, because that's going to give us a port. We're in the alignment where we want, and that's going to help us to align the socket and the prosthesis, because the way we make it is in one piece. So that's going to tell us where I want to put the model for the alignment of the tube that's going to be underneath you. And that's you inside with all the details. Alright, so now we're going to take a few measurements of the other side so we know how tall to build it and all that stuff. He's tall, so you're going to see, I'm looking at, see right here is patella tendon, Francesco? So what would you say for a length?
I'll say 19 and a half, I guess.
30 here.
Size choose the way?
That's over here centimeters. See, length of foot, 30 cm. You got a shoe for me?
He has a, you need it right?
Right.
All right. Okay, ankle circumference is 9 5/8.
Ankle 9 and 5/8.
Calf is 16 and a half.
16 and a half.
And color, we got to get a swatch. This is how we match the color of the skin. It's color by number. Right, that's all it is. Anyone you go to church, call me.
In prosthetics, the cast modifications is the one part that separates the men from the boys as we look at professionals in this industry. A prosthesis should not be painful. It should be comfortable to wear throughout the entire day. If a prosthesis is uncomfortable, there is something wrong. The cast modifications are the part of the project where a skilled artisan understands the anatomy and reduces the model in pressure-tolerant areas and builds up the model in pressure-sensitive areas, creating an environment for the patient that's going to be a comfortable prosthetic socket. If the socket is not modified properly, the socket will hurt the patient as they ambulate on it. It's now feathered, smoothed, and prepared for molding. The model is sanded and finessed into that final shape. Now I'm going to rotate the model on the mandrel and slide it in position for forming. The manufacturing process used is called hand-draped vacuum forming. A low durometer polyethylene foam is pulled over the end of the model and vacuum formed over to create the shape of the distal end pad. It's now filed and smoothed to match the shape of the distal or the end side of the prosthetic socket. Round it all off so it's got a nice round bottom shape to it. Because remember, that's only foam. I'm going to make the insert over that. So once the insert's made over that, everything will be nicely shaped so that when he gets into this socket initially on the hard socket, he will not feel any transition from where that edge of the distal end pad is. It'll be one nice smooth shape right down. And you can see, even though it's rough, once you make the hot insert over that rough foam, it smooths right out. And that pad will end up becoming loose, not loose, but it'll be just press fit into the insert. We don't glue it in because it gives you the option. If someday in the future we need a little more room on the bottom, we can always remove that distal end pad from the insert. When we first fit a patient, we leave the seam a little thick and walk them. If they get a premature heel rise, means if the heel comes off the ground too quickly when they go into swing phase, we know that pylon's a little bit too stiff. So it starts trimming back. And you trim it back until you see the heel rise symmetrical between left and right. The seam there is what gives us the ability to adjust the dynamics of the prosthesis, which is something you can't find in any other system. For example, for new patients, we typically keep this a little stiff because you want rigidity for a new patient because they're not walking very fast yet. So you want to give them stability. But as they get better as an amputee, they require a little bit more motion because they're starting to learn how to get push off and control the prosthesis and keep it stable. At that point, we'll start trimming the seam back and make it a little bit more dynamic. Okay, now Francesco's laying up this prosthesis for molding. I'm just going to clean the pylon a little bit, make sure it's dry and clean, so the tape will adhere to it. We already found a hole in here, which we're going to use for the layup, because part of this thing is, once this thing is molded, it has to be, we have to extract it from this system, from this mandrel. Now how do you extract it? The plastic is going to cool, it's going to shrink, and it's going to collapse down on top of that mandrel, tighten it up so tight that you need about 2,000 pounds of traction force to remove the plastic from the model, from the whole system. So what he's doing is putting a ring in there, which we call a retaining ring, alright, and then a nail through it. The retaining ring is going to keep the model from sliding down the pipe when you pull the plastic off of it. Alright, now he's pulling a layer of very thin nylon. The reason for that layer of thin nylon before the insert is very simple. The insert could trap air, and you don't want to do that. You want to kind of a complete vacuum system between the insert and the hot plastic on it. Now, what he's doing now is laying up tape. So we're going to put this in the oven at about 380 degrees, okay? The oven already dropped down to 315 because we had the door open for a minute. But this is an infrared oven. It'll climb back up to 380 in no time. And right now it's on run, so it's on, so it's actually increasing its temperature. You'll see it start to climb.
Okay, that's the cone. And you put a little bit plater. One it doesn't make, like you see in the back right here, make a good contact, but in the front, it didn't make a good contact. So what I do, and I just fill it up with a plater, and I make one line straight. Okay, so now you open a little holes in the deep part of the leg too, to make sure that you get suction. It's nothing crazy, just a little bit holes. It's enough to get some vacuum and pull the plastic down on the places. A little bit in the front and a little bit in the back. It's a little bit holes up here. Okay. So you see now, so you got over here the holes over here. And you got the measurement over here, which is he's 20 plus 3 inches of the foot you got, so it's gonna be up around here. So we got enough room between the pipe, between the foot and the foot pump. Okay, so you pull over this one. Now, once you put it on, you're just making sure that the lines are straight. See? Now you take a little piece of thread, you pull it here. Just cut it a little bit, not too tight. But now you're gonna be ready to pull on the pipe to mold it, but you gotta make sure that you have enough material up here so the plastic don't choke through it. So what you're doing is I just use a little extra piece of salt.
Always, you know, doing something.
Okay. So now you put it down here, this one. Make sure that you got enough here, not too close. So you always got a little space between this here. You just make sure that you fill the space with stocking it. Tighten it the way you want it. For center paper, we're gonna use it. Just keep it to clamp it up here, staple it, and that helps you too. You don't to the plastic, don't choke into the pipe. You see, you hold it. See, you hold it this one, so they will hold it to the plastic. Those will go through the pipe, don't like choke it. So that help you for that part. Then you sign it down here. A little bit down here. So just make sure to have 2 corners to make a knot. So just go in there.
The vacuum pump is way up there in the rafters.
So not take it tiny well, and that way it will help you too. Like if you have the tiny socks up here, will help you. It won't let the plastic choke to the pipe. So you just make a little bit knot up here.
Caulk is, that's just window caulk. It makes a really nice seal when you got the hot plastic going down on it. Yeah, you can keep going. Staple. And so what we're going to do is wet this soon, because water happens to be a very good barrier, natural barrier, so the plastic won't stick to the stockinette. He's going to pull some of the tension out so that the AP can be maintained. And he's going to pull that so that the suction can pull into the popliteal area and staple it so it doesn't loosen. Alright? And now we'll wet this. Now the water mixture here is, if you're going to do a ½ gallon of water, you want to do about maybe 3 or 4 ounces of Palmolive soap. And the reason why you add Palmolive soap is because cotton stockinette has sizing in it. And sizing prevents the water from sticking to the stockinette. But soap kills the sizing. And notice how it soaks right in. It soaks right into the stockinette, because you want to make sure that the stockinette is somewhat damp. Now if you notice, he really soaked it down good on the cast side, but notice he's leaving it dry in the mandrel. The reason why he leaves it dry in the mandrel is because you want to wet that only at the last moment just before you form, because if you leave that wet for a long period of time while you're waiting for the plastic to heat, the tape will swell, and you don't want the tape to swell. So you don't want to give the tape a chance to soften up. So right now we're going to leave it upside down, keep so that this is going to end up the wet spot, and this is going to be the dry. We'll be molding in about 5 minutes. When the plastic reaches forming temperature, lay it on, lay it out. Notice he did you a favor. He put it on a little angle, just like a checkered flag should be. And you rub it in.
All right.
Ready? You turn the vacuum on. Now we're going to pull the plastic out. Now we've rotated it. Get the angle right. There's your image. Okay? One shot. Boom. Now I'm going to grab here. Watch. I'll pinch and pull, manipulate. Now he can stretch all he wants. Okay? Now what I've done is maintain the thickness of the pylon all the way through, and now the vacuum is kicking in already. You'll see it. Now he rotates. You've got time to do this, but you only have a limited amount. Now it's been rotated. We're going to trim off the back. Watch this. Now while it's hot, we're going to trim off this excess. and take a carpet roller and just pinch this over so it's centered in the middle and double, because that's a high pressure area. By doubling it, now you've reinforced that seam. It's never going to split apart. Maybe get in over it so you can see that image there. And you can see in the pylon area, right in here we can also rub a little bit if you want. Mold that in, doesn't really matter. But it's here where you really want to tighten it up. And you can see the thickness of the pylon is all the way through in here. Double thick, no air bubbles.
See now, after you cut it off everything, like the leftover plastic up here, you like open this part over here of the cast. Now you can take the leg, use 3/4 drill, and you open a hole. This can be 3/4, or you open a hole. Not too long on the side, but make sure they have enough plastic to pull down. So open a hole around there. Make sure that you don't touch the pipe either. Get this done. Down, and you this side the pipe. That's why you make the whole 3/4 wide, and that way you can fit this pipe well. So now just make sure it's in the center. You pull it up. There you go. And now you got the leg on, and you got the insert up here. Start to peel off everything off. Like you saw when we set up, now you cut off the tape back off, take it off the cone, and you got the insert with that side, with the shape of the leg.
The prosthesis trim lines are now determined. Things move very quickly in New York. At this point it's rough trimmed, polished, prepared for assembly. Now we begin assembly of the prosthesis in the shuttle lock. A hole is drilled in the medial side to accept the plunger. The collar is assembled into the shuttle lock, which anchors the shuttle lock into the pylon. And a pin is cut to the length for the button. The pin is placed so that it's just below the surface of the foam cover when it's finished. It's tested. And now the foot clamp is assembled on the prosthetic foot. It's bonded to the foot with cyanoacrylate adhesive and a bolt. The surfaces are cleaned and etched so the adhesive will bond plastic to plastic. The bolt actually has no strength at all. It's the adhesive that holds the foot clamp to the prosthetic foot. All the bolt does is prevent any movement. It needs to be glued and screwed. Before tightening, it's positioned so that the foot clamp is in line with the line of progression, and then it's tightened down to about 50 foot-pounds. The nylon foot clamp can tolerate up to 90 foot-pounds, but 40 is what's required for a prosthetic bolt attachment, and we do it to about 50 just for a little insurance. prosthesis was re-measured and adjusted for length, and now the seam is feathered to the appropriate flexibility. Final assembly, polishing, and the prosthesis is now ready for a fit. One last check for length. The insert is put together in the socket with a nylon. Socks are prepared for the prosthesis and packaged with the instruction sheet. It also has cleaning and care on the back. The pins are Loctite to the liner. And Mr. King is now ready to run.
Right now we're going to start with the insert. You see the insert, that's the one he was showing you yesterday, the pen inside. And I don't know if you're going to be able to use it right now, maybe because it's too thick when you're not going to be able to get into with the insert. Or you got to try with maybe 5-ply. And okay, here we go. This is the pad, the way we're going to use. This pad, you use it when you're not using the insert. When you're using the insert, you don't have to use it anymore because this is inside already the insert. But right now, maybe you're going to go with the socks. So you're going to use this one and the socks. First thing you're doing is you put the liner on. Now, you put it like on, like the same way as you did yesterday. I'm going to do it for you the first time, then you do it the next time yourself. Okay? It's going to be a little bit tight in the beginning. The first time going to be a little bit tight, but with the time we're going to get the shape, right? You see? It's right there. You're going to be like this. You see? This is the way you're supposed to put it on. Alright? Alright, we're going to start with 5-ply. Let's see, 5-ply and the pad. But with the time, you're gonna start to use the insert. Right now it's too big. Right now your leg is too big, but it's going to shrink. Once you start to use the leg, it's going to shrink. And you see that pad have the liner here. That's the going to the front. It's got the shape of your leg, you see? See, but you got to make sure that this line's in the front. And you're doing this after the liner, then you put the socks on, and that way you keep it, you hold it together. Okay? You see? There's a little hole up there, and then you put it, and make sure that when you put it on, the pin is clean. Guys, you're gonna hear some click when you get into the pin of the lock. Okay? Just press down on your leg. Huh?
Now he feels over your hips to see how high the hip is, and then we can tell exactly how much we have to shorten it. That's how you measure it, because he's got to load both sides evenly. And then when you see the pelvis off, you can see it.
I'm going to cut it right down so I can measure it now.
An inch?
Yeah.
Okay. Yeah, it says the half. Remember the half we talked about?
Yeah.
See, when we measure it, I add a half. When they build it, they add a half, and then when we fit it, we cut an inch off.
Because it's no more anatomical angle.
He's off and running. Okay, now you can throw the walker. Now, the way to check this thing is the way we trim our sockets is your kneecap should sit, see this little low area here? Your kneecap should sit right in that spot, because below it is the patella bar, which is really where you carry a good percentage of your weight, so that's the tendon. And now when you feel it, the top of your patella, you're in the right place in the socket. Now, you should feel pressure here, but you shouldn't feel pain. Now you want to put even weight on both legs. Line them up about 6 inches apart. That's it. Now the same weight on both sides. Shift over to the right a little bit more. That's it. Yeah, you're still hair tall.
can take that leg off and hop from here out to his car.
Any pain?
No, I'm alright right now.
I think we should have some more socks. So right, go
Yeah, well, he tightens up quick, and I think that foot's maybe moving.
Yeah, you need it.
Because what's going to happen now, he's going to shrink real fast, because he's busy. This is his first day on a prosthesis. Come on, he's running already. So what's going to happen is that body is going to shrink so rapidly that
You gonna
it's going to
smile?
become uncomfortable.
Are you happy?
Yeah, I'm happy.
Okay, alright.
Do you want my another sock like maybe 3 ply?
Another 3, give him another 3.
That'll
Yeah.
do that.
He'll feel better too.
So like on the side, you should.
The way you adjust the volume is by... Yeah, if you hear 1 or 2, you can stand on it.
There you go.
There you go. And that's why the pin is serrated all the way down, so you'll keep going and locking it.
Now you're gonna feel like softening because there's more ply there and a little bit tighter.
Okay.
Okay, go ahead, walk.
See the way he's walking? He's got his hip rotated a little bit.
It's kind of like super.
Yeah, and now look, this is what you need to do. I think your hip is rotated only because you've been sitting on that leg for a year with nothing to do with it. And what happens, when your hip is rotated out, what happens is the foot swings this way now, not in line with the line of progression. So, feel my hip right here. Put your finger right here and watch. All rotation comes from the hip. Look. You see that? Do it on yourself. Now, see if you can bring it in. Good. I think you need to toe the foot out a little bit more so it trains him, because you got the foot toed in just to look normal against the other.
Right,
But
right.
you see he's externally rotated hip. I would toe the foot out.
You want me to walk like this?
No, we're going to adjust the foot and set it back to where it should be. We're going to set it in the correct line, and then you'll learn to train it to come back in.
Don't worry, I'm just gonna fix it right there.
See, because a whole year with nothing to do with that leg.
I know it
That
hurt.
hurt. Oh, jeez.
It's just your foot.
Just, I have to do sometimes. So we're going to do a little quick amputation. Take the foot over.
Right there, don't move.
Come on.
More? So
A
out.
little more. That's good. See, we're going to set it in normal alignment. So you get trained. Now, what you're going to do is look in the mirror and try and match those feet. So right now you're going to see the right foot is out too far. Try and turn it back in. Now we can always move it, but I'd rather you learn to go straight first. Now look in the mirror when you walk.
It's a lot out. It looks like it's a lot out, but when
But
you
watch, yeah, see, you got to kind of fight it right now. That's where you want to be. That's it, beautiful. And watch the mirror, don't look down. See, because when you look down, it throws your whole posture off.
Yeah.
Much better. I know it feels funny right now,
Yeah, it does.
but it will get better.
Maybe that was the way he walked before when.
Well, no, you know why? Because he had a whole year with an amputation. No leg. So that leg had no function for a year, so it just hangs.
That do feel a little funny though.
Yeah, it's going to feel funny. You're kind of fighting it.
Because it feels like I'm like turning my knee.
Right,
all
I
the
know,
way in.
I know, I know,
You gotta get
I know.
used to.
We can always move it.
Well, I'm sitting down in the San Antonio, waiting on an 8 o'clock train.
Prosthetics is an unusual industry. We call it reverse engineering, because first we build it, and then we adjust it to make it perform.
I gotta get back to Dallas and tie up a few loose ends. I'm on a work a week, I make $100.
The alignment of the prosthesis is a term used for the relationship between the prosthetic foot and the prosthetic socket. The position of the foot with regard to the prosthetic socket is important to maintain the proper alignment.
Cause this ain't gonna be the first time this old cowboy spent the night long.